All right, ladies and gentlemen, so today we're going to start learning something called polynomial arithmetic. Say what? Polynomial arithmetic. Now, home-based learners, make sure to stay muted the whole time, everybody, because I am recording this and I would like this recording to be, I don't want because if you talk, your name will pop up on the recording and I'll have to go in there and clip it out. Polynomial arithmetic. Poly means many. Nomial means terms. So polynomial means many terms. Monomial means one term. Binomial means two terms. Trinomial means three terms. All other polynomials are named according to their degree. the degree of a polynomial is equal to its highest exponent. Okay, monomial means one term. An example of a monomial would be 5. Here's another example, 3x. You might be thinking, now wait a minute, I thought you said one term, and there's two things here, 3 and x. Just watch, and you'll see. 9y squared, 2/3, -1. Those are some examples of monomials. Just wait until you see what a binomial looks like, and then you'll understand that it's okay. Here are some examples of binomials. So what's going on here with the binomials? The binomials are separated by addition or subtraction. There's two things inside the parentheses. So this is one binomial here, okay? This is one binomial. This is one binomial. So the idea is in order for it to be a binomial, it has to be separated by addition or subtraction. Must be set by addition or subtraction. See, up above on the monomials, you have the 3x. That's one term because it's multiplied 3 times x. Below, you've got x plus 3. That's very different than 3 times x. It's 3 plus x. Now let's look at trinomial. Here's an example, x plus y plus z. Five x squared plus 3x plus 4. Okay? This one right here is a special type of trinomial called a quadratic. But we'll learn more about that later. It's quadratic because the highest exponent is 2. But that's for later. Are you done writing? Not yet. Okay. So today we're going to focus on a specific type of arithmetic called multiplication and a specific type of polynomial called a binomial. So today we're going to learn binomial multiplication. And this is very common, very useful. It will come up a lot. And the best part is it's easy. But first, a couple of ground rules. Polynomial arithmetic is commutative. That means order doesn't matter. So let's take a look at an example. This is the big one. A plus B times C plus D. We're multiplying one binomial by another binomial. And this is a big moment. There will never be a time that you will go back to in your life in the future where you don't know how to do this. Okay, so up until now, I don't know that anyone has ever shown you how to do this, and now you're going to learn how to do something really useful and important. It's really easy, okay? This is equal to A times C plus D plus B times C plus D. Very similar to the distributive property. You're distributing this A to both terms right here, and then you're adding, and then you're distributing this B to both terms right here. Okay? So the next step would be to distribute in these little sub-problems. Like you have two smaller problems now. So this would equal AC plus AD plus BC plus BD. You need to see an example, okay? You need to see an example. Don't do the addition inside the parentheses. Treat it like it was letters. All right? I want to demonstrate something pretty neat. So let's follow this procedure. We're going to multiply the 1 times 3 plus 4 plus 2 times 3 plus 4. So we're going to write 1 times 3 plus 4 plus 2 times 3 plus 4. And then we're going to multiply the 1 into this parentheses and the 2 into this parentheses, okay? 1 times 3 is 3. Here I want to write it out. 1 times 3 plus 1 times 4 plus 2 times 3 plus 2 times 4. Okay, so simplification. 1 times 3 is 3 plus 1 times 4 is 4 plus 2 times 3 is 6 plus 2 times 4 is 8. What's 3 plus 4? What's 7 plus 6? What's 13 plus 8? So this whole thing is 21. Now let's check and see if that's right. What's 1 plus 2? What's 3 plus 4? What's 3 times 7? Wow, it's pretty neat. So we arrive at a conclusion. Here's the conclusion. Binomial multiplication changes a multiplication problem into an addition problem. Wow. Okay, wow. Much wow. Get a fresh sheet of paper or turn to the next page or whatever. And we're going to do some examples. My first example, here are your, this is like your little problem set of examples. One. And on these problems, treat them like they're letters. So go ahead and show that whole process as opposed to just adding them together and multiplying, okay? Treat them like they're letters. Please take 10 minutes to do these 5 problems. Show nice, neat work. Okay, let's see how we did on binomial multiplication. Problem number 1 was open parentheses 3 plus 2, close parentheses, open parentheses 1 plus 4, close parentheses. Okay, so I'm going to multiply 3 times 1 plus 4 plus, then I'm going to multiply 2 times 1 plus 4. It's 3 times 1 plus 3 times 4 plus 2 times 1 plus 2 times 4. Here comes the part where we've converted this from a multiplication problem to an addition problem. 3 plus 12 plus 2 plus 8. And now it's an addition problem. Well, 3 plus 12 is 15. 15 plus 2 is 17. 17 plus 8 is 25. Is that right? Okay. And let's check and see if that's right, okay? So 3 plus 2 is 5. And 1 plus 4 is 5. 5 times 5, 25. All right. Let's do number 2. Um, 3 plus 6 times 9 plus 1. 3 plus 6 times 9 plus 1. So that's going to be 3 times 9 plus 1 plus 6 times 9 plus 1. Well, that's 3 times 9 plus 3 times 1 plus 6 times 9 plus 6 times 1, which is 27, plus 3 plus 54 plus 6, which is 30 plus 60, which is 90. Let's double check that that's right. 3 plus 6 is 9. 9 plus 1 is 10. 10 times 9 is 90. Okay, so it works. Number 3. Five plus 0 times 2 plus 0. 5 plus 0 times 2 plus 0. Well, that's going to be 5 times 2 plus 0 plus 0 times 2 plus 0. Okay. 5 times 2 plus 5 times 0 plus 0 times 2 plus 0 times 0. That's going to be 10 plus 0 plus 0 plus 0 equals 10. And let's double check that that's true. 5 plus 0 is 5. 2 plus 0 is 2. 5 times 2 is 10. Neat. Okay. If I were you at this point, I would say nifty. Okay, that's what I'd say. Nifty. Moving on, number 4. X plus 5. You knew it was coming. The letters. X plus 3. Well, we're just going to treat it just like the other deal, okay? So it's going to be x times x plus 3 plus 5 times x plus 3. Well, I showed you there. Remember, x times x is x squared. That's important. So x times x, I got x squared, plus x times 3 is 3x. Let me write that intermediate step. I want to keep this consistent. So I've got x times x plus x times 3 plus 5 times x plus 5 times 3. X times x, that's x squared, plus x times 3, that's 3x, plus 5 times x, that's 5x, plus 5 times 3, that's 15. Now, these are common. 5x and 3x can be combined together. To be 8x. Okay, and that's the answer. X squared plus 8x plus 15. Raise your hand if you got that. No? You cannot add that x squared to this x here. And that's because the square actually makes it to where it can't be combined. It's almost like a different letter. Okay? Only can be worked with on multiplication and division, but you can't combine them on addition and subtraction. All right, last one. See if I can do it before the bell rings, huh? X minus 2 times x plus 1. Here we go. X times x plus 1 plus negative 2 times x plus 1. You guys, we still have 2 minutes. There's no need for the clanging of backpack sounds. So that's x times x plus x times 1 plus negative 2 times x plus negative 2 times 1, which is x squared plus x minus 2x minus 2, which equals x squared. Now I've got 1x minus 2x, that's negative x minus 2. Okay, because these again were common here. Okay, well, there's no homework today, and I would say, having watched this, I would say that the response walking away from this should be a